Welcome everybody. In this video, we're going to be talking about classes in Python and how we can use them for our data collection purposes. Now, if you're not following along with the data collection series, you can still watch the video to learn about classes if you've tried to use classes and you're struggling with them. This video should help you. My name is Anton. Welcome to the Raw Coding YouTube channel. Don't forget, if you're enjoying the videos, leave a like, subscribe, and if you have any questions, leave them in the comment section. Here we have the virtual environment set up and the 3 scraping projects. Now, first of all, we will do a little bit of scraping today, but what we want to do first is understand classes. So let's create a test.py file. And what we have worked with up until now are essentially functions, and then we had some data, which is essentially a dictionary. So we create some kind of process, and then we create some kind of data, and we try to orchestrate the two. Data and functions are pretty much free-floating on their own, and the only organizational feature that we currently have are files or bodies of other functions. If all the data and functions in your code are kind of free-floating and don't really aggregate anywhere specific, it may be a little bit hard to reason about your code. Now, you can bring in classes to essentially define what the data model may look like, and it's not going to allow you to go outside of the constraints that you have specified. Likewise, for the function side, you can define a class with specific functions, and then when you're inspecting some kind of use case, you know, I can find this class with these functions, and I can see the full interaction happening there. So we can use classes to represent data or processes a little bit more specifically. Let's see what a class looks like. So instead of functions and data, we'll say class. And first of all, we will create a phone to represent some data. Now, the important thing with classes is that class itself is a blueprint, and then a blueprint is used to create objects. You only have one blueprint, and then you can create many objects as your program is executing. So a blueprint exists at compile time, so essentially only when the program is read in. So here, what we're doing is we're defining a blueprint. Strictly for example purposes, this is going to be a field that belongs to the blueprint, and we will assign 1 to it. I know this may look exactly like a function where we create a variable and we store 1 in it. However, this field exists inside the phone blueprint, inside the phone class. If we go to print phone and then field, this is how we would reach this field, and if we run Python 3 test.py, we're going to see 1 being printed to the console. Here we're interacting with the blueprint. If we want to create the object counterpart that I was talking about, we have to take the phone and call parentheses on it. This is going to trigger the construction process and allocate an object in memory. Here we're going to have an individual phone. However, the phone is still going to share the members which belong to the blueprint. So let's take a look at this. We'll take the phone and replace the class phone with the variable phone. We'll rerun the application and we will see 1 being printed. Now, as I said, you can create multiple phones. So let's move this over here a little bit closer, and then we'll place this here. And this is going to be phone 1, and this will be phone 2. And both of these will have the same field. If I run this application, 3 ones get printed to the console, no problem. Well, there is actually one problem. If we take the phone field and we change it to something like 2, and we run the application, we have essentially mutated both of these objects, even after their creation. So let's say we have created the 2 objects, so somewhere away from the blueprint, and then we have changed the blueprint and we run the application. We have changed the objects, and that is not because we're actually changing the object, it's just that the field on the object will refer to the field on the actual blueprint. So the object, the final house that we have created, still has reference to the blueprint. Now, the powerful thing about classes is that we can actually create instances which are going to contain their own information. If we want a field or a variable that is only going to be contained on the final object, we have to do the following. Let's say we will create a function and we will call it setModel, and we're going to supply the model parameter over here. What we actually have to include as the first parameter is self. Self is going to be referring to the individual object. So what we do is self dot, and on the self, we set the model to the model that we're passing to this function. So when we grab phone1, and I know this may look a little bit confusing, we're going to call the setModel function, and we're going to say that this is an iPhone. For phone2, we're going to say that it's an Android. So phone2 over here, we'll then grab the model and print it out. Execute the application, and we see two iPhones. I want Android over here. I will rerun. And you can see here that phone1 contains iPhone and phone2 contains Android, while we're setting that all up before we're actually trying to access the model. If we create a phone without the model, we're gonna get an exception. So you wanna make sure you have initialized these properties before you try to use them. You wanna eliminate this gap over here between setModel and the construction. And we can actually do this by moving the initialization into the constructor over here. Let's go ahead and delete all of this, and in order to use the construction process, we're going to define an underscore init function, and here again the first parameter has to be self to refer to the object and not the blueprint. If we call field like this, we're not referring to this variable over here. If we want to refer to it, we have to do it through the class. However, what we really want to do is refer to the model on the object and pass the object as part of the construction process. So the model over here, set the model, remove the setModel class, and then when we create a phone, in the constructor we say that it's an iPhone. And then for phone2, we say that it's an Android, and then we print out the phones. So rerun the application. When you're printing them out like this, you're just gonna get the reference to where they are in memory. If you want to convert these into a dictionary, you can actually use the vars function, similar to the map or print function. It is available in the global namespace. If we rerun the applications here, we can see that both of these objects will contain different data, even though that they're both phones. And this is pretty much how you define data classes. However, some data can vary from other data, so sometimes you're gonna have a model, sometimes you're gonna have a version, sometimes you're gonna have what year has the phone been made in. So you may want to make some data optional. Let's say that model from the beginning is going to be empty, and that the version of the phone from the beginning is going to be empty as well. When we're creating the Android phone, we're going to include the version and say that it's, I don't know, version 12 or whatever it is right now. We have to not forget to set the version on the actual object, otherwise nothing is going to happen. And when we rerun the application, we're gonna see iPhone is not going to have a version and Android is going to have it. We can also, instead of setting these to empty strings, you can set them to none. And if we rerun this, we'll see that version over here is set to none. If you're serializing this to JSON, you're gonna get a null. One more important thing to note here is that data classes can still contain functions. So you can have a function like getVersion, and you will return, parsed by an integer, the version from the self. So for this, you actually need to include the version in the function. Grab the version of the object. If you are not going to have the self, you are going to try to refer to a variable version, which is not in the function, right? You want to grab it from the self, and the self is automatically attached here. Now, if we just run the application, nothing happens to this version over here because it is going to be the field on the object that gets serialized to the dictionary. However, we can still reach that from phone. So phone2, get version, call the function, and we're gonna get 12, not the string, but the number being printed to the console. Having a function like this on data classes doesn't really make sense. However, it makes sense on the interaction classes, where you're gonna have a bunch of functions, each with their own responsibility, and all of these functions are going to make up a use case. The use case that we're going to be modeling is BBC Food. So let me make sure you can all see this. We're going to build a scraper that is going to be looking for pizza. We're going to do something like this: input pizza, enter. Here we can see the URL at the top. Let's head on over back to our scraping logic. So scraping. Let's create a new folder. This is going to be BBC_food. Inside of here, we will need to create an init file to make sure that it gets recognized as part of our package. Let's go into blog main, and we're just gonna make sure we grab the entry function because I forgot what it was. So def default args. Let's close this. Again, let's create a main py and BBC food. put the function over here. And instead of pages, we are going to have a search term. We'll then again focus on the BBC Food folder and create a collect recipes.py. In here, we'll create a class, which is going to be a use case. So collect recipes. That is what we want to do. If we have some kind of tools that need to be injected into the collect recipes, we can do so in the constructor. Otherwise, we can just start defining our functions, like start collection. And here we're going to have a search term. And then we're going to need to import requests. From requests, we're going to get what kind of URL? Well, this URL. Let's put it over here. And actually, this will need to be a string. We will need to string interpolate our search term into here. So search term, this is going to give us a result. From parcel, we will need to import selector. I wasn't getting any IntelliSense here, so I had to go to this option here in VS Code to basically change my interpreter to global and then to the local venv again, and it looks like I have, well, got my IntelliSense back and I can actually write code, right? So selector, in the selector goes the text. This is gonna give us some queryable HTML. Now again, we can go into BBC Foods and create a folder like models. So what kind of data models are we going to collect? Let's say that one is going to be recipe.py. Let's introduce a class recipe. We'll then define a constructor. So in it, I'm getting a little bit of code completion. I'm going to remove the type hint for the return and then remove the pass. The pass is essentially if you don't want an implementation for a function, so you want a function to do nothing, you put a pass in there. Let's come back to BBC and, let's see what kind of results we can get. I can see things like title, description, we then have time, how easy it is, and then perhaps some kind of features. So let's document this here. I like to put this on multiple lines when I have many parameters in my class constructors. We'll have title, we'll say that maybe it can be empty, there will be description, it will be empty as well. I'll then have time, so how long does it take to cook, difficulty, and then there are options like is it vegan, is it gluten free. Cool, I can now use the middle mouse button to drag it over multiple lines, use Shift and Control to jump over, select and essentially jump a word to copy it all across, and then paste it down here in the body. Again, I'll put my middle mouse button here to essentially select these and put on a new line, and then again, I will select it yet one more time, make sure I type the self in front of all of them. I can then use Control right to jump to the right, and then equals, and then again paste the names. So all of these parameters will get assigned to properties. I'll format the code, and this is pretty much our recipe. We can now go into collect recipes. This is going to be a recipe that we want to build up, and we want this to be a well-defined function. Create recipe from some kind of HTML, and from here we can return recipe as long as you spell it correctly. You don't need to be scared that it's not being imported. You can bring up the quick actions menu and actually import it then from the scraping, BBC Food, models, recipe namespace, and now you have your recipe, which you then need to fill out with all the relevant properties. Let's jump back over here. We're gonna right click, we're inspect, and let's take a look at what we're working with here. Each one of these is a standard card new and standard card new skinny, and I just noticed probably need this a little bit bigger for everybody to see, a little bit more. We have the individual row, which is slightly bigger than a row, and then we have the individual columns. So they seem to start here at template search universal card. So I'm going to collapse one child, and it looks like I can actually go down here. And this class looks a little bit more friendlier, where you have standard card new. I'm just going to go ahead and copy the class in the HTML over here. I will use XPath to grab all of the divs with the class that is going to match this, and I'm using back quotes, so double quotes on the outside, and I don't know what this is. Let me close that down. I'll call get all on this. This should get me the recipe nodes, and then for each recipe node, so for node and recipe nodes. I want to create a recipe, remember that in order to reference this function, we actually need to do it for the self. So self over here, and then self over here, create recipe, pass the node inside of there. That is going to be the second parameter. This function is going to return a recipe, and we can actually hint at this. So let's say recipe. If we do recipe this way, VS Code is actually smart enough to realize that this function is going to already return the recipe. If we want to put a type hint on the variable like this, we can do it this way, or we can also do it this way, right? It's just your preference at which point you want to put the type hint at. And then, well, as we can see in this example, actually VS Code is already capable of figuring out. I'll remove this recipe and I'll actually create kind of like a final results thing. So results equals array, and then results, I will append the recipe to it, recipe, and then return the results from here. I'll remove these couple lines, and let's work towards, fetching the stuff for this recipe. So inside of here, let's zoom in on the pizza sauce. I haven't done a good job of that. So again, standard card new article item on the HTML node. Again, I can hint that this is going to be a selector, so I can get my XPath syntax highlighting. I'll say that somewhere in there, so make sure I use dot. If I just use double slash, it's gonna again research globally. Somewhere within the current element, I want a where class equals this thing. This is going to be the title. And then I want to do the same for the other properties. And since this is mostly going to be simple stuff, I'm probably going to cut here. So a couple of notes here. I haven't run this yet. I'm making sure that I'm going into /text to grab the text, and I'm grabbing, I'm calling get to make sure that I evaluate this selector to actual text. And then for the additional info, what I'm doing over here is because all of the classes over here are pretty much the same. So for example, you can see that the time and the difficulty are all the same. I'm gonna grab the standard card new additional info and then iterate over child elements to get the data that I want. Here's my final result. I get the text of all the additional infos. For time, I just grab the first one. For difficulty, I grab the second element. And then vegan and gluten-free, I check if that is contained inside the additional info. Let me drop down the terminal, and since, most of the logic is pretty much done, we're gonna come back into this main py, and the easiest thing is probably grab the collect recipes, go over here, paste collect recipes, import this in. So this light bulb over here, you want to import. You want to then call the function on this. You can store this in a variable if you want, but let's call the function. You have a start collection. We will then input the search term and return the results from over here. And that should be pretty much it. I have all of these imported as development, by the way. I'm going to go into setup here and remind myself of the scrape command. So scrape bbc underscore food, we'll say pizza. And we have some error in main.py on line 6 and inside run. So let's jump over here because it's pizza. It cannot be parsed to an integer. So let's go ahead and fix that. Rerun the application. It looks like that has worked. So what do we have in the output? Nothing. So let's take a look. We're gonna go into collect recipes and see if we have any recipe nodes. So print recipe nodes, rerun. And looks like it's empty. Get all will return a bunch of strings, so let's just make sure that we're getting elements first. Looks like we're not getting anything, so let's see what the HTML is, or actually we can verify the XPath first. So coming over here in the elements, I'm gonna paste the XPath, and it looks like I'm getting the individual elements. So now let's make sure that this exists in the HTML that we're scraping over here. I'm gonna put a simple debugging open. This is just gonna be test.html. I'm going to write this as f and then f write HTML. Oh, I don't want to write HTML, sorry. I just want to write the text of the result or the response. Let's rerun. Got test HTML over here. Let's come back to collect recipes. I'm gonna grab the standard card new, copy that, paste it into here, and look at that. This has a couple of new lines, where in here we don't. So let's see if we can do anything with the outer element. And by the way, this HTML looks all kinds of messed up. So here is the element, and I don't know why my scrolly wheel is so sensitive, but here we have the div and here we have the outer div. So hopefully we can actually rely on this bit right here, or col12. So this bit, let's see and make sure that it's the same out here. So it looks to be the same. So let's grab this instead, go to collect recipes and replace this with this. Hopefully it's going to be a little bit better format, so we will actually get some stuff. Let's rerun the scrape, and this time it looks like we actually have things. First of all, let's make sure that whatever exception is happening here is not something that we haven't handled. So the way that you do this is, let's remove the prints first. We're gonna go down to create recipe. I'm gonna drop down the terminal. You essentially put a try and then accept some exception. We put the construction process at the top over here, and then return none if we have an exception. If the recipe, and we can check if it is not none, but if you're saying if recipe, you're assuming that it is present essentially. I'll remove this line over here because, well, I don't think it's needed. Let's rerun and let's see if we're getting anything at all. The test HTML, I don't think I actually need it anymore, so I'm going to remove it. I'm going to check the output and I still don't have anything. So I still have some kind of exception. So let's actually now take the time to read this. This was on line 28. We had additional info 0 and a list index out of range. So collect recipes, additional info, nothing must be here. So let's print and we'll take additional info. Potentially this is suffering from the same problem of the classes being spread across multiple lines. I really don't know what that is. Let's go ahead and rerun this, and looks like it is. Let's take this class that we have here. I'm already regretting the deletion of the HTML, although I can press Ctrl-Z and that will bring the file back. Searching for this, I can see that there is nothing here that represents that. So what I'm gonna search instead is for pizza sauce. Over here, let's see, we have 78 ratings. If I scroll a little bit further down, there is some kind of picture and then pizza, margarita, and 4 easy steps. So that is already the next thing. I want to go slightly higher here. The picture here is still for the pizza margarita. Going higher, this must be the beginning of the pizza margarita, and over here must be the rating thing. I can't see it. Let's search for our rich. And it looks like there is actually a big JSON blob that we can search from whatever this JS search data that we have over here. So let's actually utilize that instead of trying to, go through this bastardized HTML. We're gonna come back to collect recipes. We're gonna come over here where we have the XPath, and if we come back to HTML real quick, this is gonna be in the script with this tag with JS search data class. So collect recipes, script, class is going to be this. This will be the text that we want to get here. So text, and then get. This is going to be some kind of JSON string, so some JSON data. We'll then want to use JSON. So at the top, import JSON. From JSON, let's load string from JSON string, and there should be some data here. Let's just make sure that we are actually getting this data. I'm gonna comment out all of this stuff, rerun, and here in the terminal we do see some kind of JSON data, which is cool, means we can actually iterate over it. So let's see what the data looks like. If we come back to the HTML, there is going to be results, and then that is an array with some kind of objects in there. We will go to collect recipes. We will take data. We will uncomment this. We will go into data, and in here there will be results. So test HTML, let's just double check that the keys are correct. I will then print the individual node, rerun the application. Probably worth putting a quick break here so we can actually see what's there. Opening this up a little bit. There's a little bit more data here than I anticipated, so let's take a results and actually just append the node to here. We'll rerun the application. We should now see this in the output where I can format it and actually extract the data that I want. So in the array, I'm going to get this object and there is going to be this information in here. So we're going to have title, description. Let's come back to over here where we no longer have the HTML, but we have the recipe data. We no longer need this malarkey. Let's get rid of the try catch exception. Let's unindent this, and from the recipe data, let's extract everything that we need, which is going to be the title, description, double checking the time, so total time array and total time human readable, just like that, and now the difficulty. So the recipe got this taxonomies thing, which has the difficulty, and then the vegan and gluten-free stuff. So let's go ahead and add this in. First of all, let's start with the difficulty. So taxonomies, difficulty, and name. And now for vegan and gluten-free. If I look for taxonomies diet, this is going to give me this array. I will then want to extract each individual names out of each of these objects. What I'm going to do for this is I'll use map. I'll provide a lambda where X is going to be the recipe and the iterable object is going to be the diet over here. For each X that I'm going to receive, I want to grab the name. I'm going to turn this into a list, and then I can say that these are diets. I'll grab the diets and I will search for vegan and gluten-free in these diets. So let's take a look at the output. Vegan should be found, vegetarian could be found, although I'm not looking for vegetarian. Let's just make sure that I spell gluten-free. That looks like a hell of a thing to spell. There we have it. Let's remove this code over here. Open up the terminal, rerun the application. List indices must be integer or slices, not strings. So let's take a look. This is crashing here. Taxonomies is an object, difficulty is an array actually, and there is going to be only a single entity in there. So when we come back over here, after difficulty, there is going to be an array here, and we'll just grab the only difficulty that's in there. Okay, let's come back over here, rerun. Another error, so diet doesn't exist in taxonomies. Let's come over here, output.json. So perhaps some recipes don't have a diet, and that is completely fine. Let's go to collect recipes, and we'll say that if diet not in recipe taxonomies, we will say that diets equals empty array, and when we're searching for it in here, that should return false. And actually, let's invert this. So from the beginning, it's going to be empty, and if diet is indeed in taxonomies, let's go ahead and set it to this thing. We'll open up the terminal, rerun the application. And what I think is our final error, recipe is not JSON serializable because it's an object. What we can actually do is convert it to JSON using a vars keyword instead of print. The same thing that we've been doing in test.py right over here. So let's come back over here, rerun. That has run successfully. Let's drop this down, take a look at the output and all of the recipes that we have managed to collect. And that is pretty much it. We got bogged down a little bit, but remember, we tried to learn about classes. So classes can be used to represent data objects which have a little bit more constraints on them. We cannot just put anything willy-nilly onto the class. We are defining what things the objects that we'll create out of the class is actually going to have. Remember, you have a blueprint, you don't just have the final thing into which you're whacking properties. On the other side with functions, we no longer have just a file with a bunch of functions. We have a class which holds all of the functions and essentially tracks the progress of the collections and says how these items are going to be created. It may seem a little bit redundant when you have only one request that you're making and you're parsing data out of that request. But if you have a whole journey of a collection, so you start with the search, you go through the recipes, and then you find all the relating recipes. So it's not just a simple get, it's more of a get this recipe, get the relating recipes, these are the conditions for following the related recipes, etc. You can represent those journeys using classes, and you can reuse sub-journeys and more bigger journeys. As always, thank you very much for watching. If you've enjoyed this video, don't forget to leave a like, subscribe, all that jazz. You know what to do. If you're enjoying the work that I do, or you want the source code for these series and other videos that I make, please come support me on my Patreon. Very big thank you to all of my current Patreon supporters. I greatly appreciate it. As always, thank you for watching. I'll see you in the next video.